Now we want to talk about prefix code. A code C is called a prefix code or prefix free code by its meaning. By name, it is prefix code. By the meaning of the code, it is prefix free code. You will see the reason soon. Or an instantaneous code if no code word is a prefix of any other code word. So if no code word in the code word set is a prefix to any other code word. So let's have an example, which is code C has a code word set, script C, given this way. Can you see any code word which is a prefix to other code words? So 0, for example, can you find any code word that start with 0 as a prefix? No, there is none. This is postfix. So it is not prefix. So it does not apply. So 0 is not prefix to any other code word. How about 10? The string 10 does not appear as a prefix to these other code words. So that's clear. How about 110? This one is longer than 110, so we can examine if it is a prefix to this one, but it is 111. So 110 is not prefix to this code word. So this is a prefix free code. And note that if it is a prefix free code, then a string like this can be uniquely decoded as this one. So 0, you see immediately you start the decoding. You don't have to wait until the end of the whole sequence. As soon as you see a code word, you stop. How about 10? This is the second code word. So you separate it. 110. 11 does not appear, so you can move on to see the next character. And the next character is 110. It appears right here. Then you immediately decode. And when you see 0 as the next character, 0 appear right here, so you immediately decode. And 1 does not appear, 11 does not appear here, 110 is the code word. So this is the decoded sequence, okay? So we note that as soon as you see a code word, you do the decoding. You don't have to wait any more symbols or character to determine, to make the final decision. So this prefix code is called instantaneous because of this property. It is also self-punctuating. Without having these punctuations, like these commas, it can be decoded. So a prefix-free code is both instantaneous and self-punctuating. So that's the definition of prefix code. Now let us summarize what we have studied. A code is non-singular if it is one-to-one. A non-singular code is also uniquely decodable if its extension is also non-singular. A uniquely decodable code is called prefix code if no code word is a prefix of any other code word. So that summarizes the whole thing that we have studied. And here is an example. Let X to be the ordered set 1, 2, 3, 4. order matters here. Consider the following codes. We want to classify if a given code is a singular, non-singular, uniquely decodable, or prefix code. Let us consider the first one. So the first one, we have, to describe the first one, we have script X, which has 4 elements. 1, 2, 3, 4. And C1 is a map. And this C1, the first one means 1 goes to 0, 2 goes to 0 as well. So this is 0. 3 go to 1, 4 go to 1, 4 goes to 1. So this one is many-to-one mapping. So C1 is singular, because when you try to go back, when you do inverse map, for example, of 0, it is singular. Basically, you have ambiguity between 1 and 2. When you do decoding 1, it has ambiguity between 3 and 4. So C1, which is this map, is singular. So that is a singular code. Now let's move on to the second item. C2. C2 is a map from 1 to 0, 2 to 0, 1, 0, 3 to 0, 1, 4 to 1, 0. Okay, so let us express that using this picture. So I need to erase a little bit. Okay, that will be good enough. So 1 goes to 0, 2 goes to 0, 1, 0, 3 goes to 0, 1, and 4 goes to, all right. 4 maps to 1, 0. Okay, so this is the map, which is C2 now. So C2, is this singular? No, it is not. So it is non-singular code, non-singular code. Now let's ask, is this uniquely decodable? For uniquely decodable code, we need to consider extension, right? Extension has to be uniquely decodable. So let's consider this string right here. Is this a string uniquely decodable? So this one 0, 1, 0 appear right here, right? So it can be decoded as 2 in set X, or it can be also decoded as 0, 1, 0, which is in this case 1 and 1, 0 is 4. So it is 1 and 4. So there are 2 ways that 0, 1, 0 can be decoded. So this is not, the inverse is not uniquely decodable. So this is non-singular code, but not uniquely decodable. No, so not uniquely decodable. All right. Also, it is not prefix-free code. Now let us have the third code. So third code, all right, is going to be defined as the first element goes to 1, 0. The second element goes to 0 and 0. The third element goes to 1, 1. The fourth element goes to 1, 1, 0. Okay, so that's C3 now. C3. Is this uniquely decodable? Again, for uniquely decodable, we have to consider for uniquely decodable, we have to consider extension, and the extension should be uniquely decodable. So C3, let's examine if concatenation of some of the code words is uniquely decodable or not. Okay, so let us consider some combination. Let's say 0, 0, 1, 1, 0. Is this uniquely decodable? 0, 0, 0 is not a code word, so we have to read one more. 0, 0 is a code word. Okay. 1, 1, 0, 1, 1 is up here, right here. But if you concatenate this way, if you separate them this way, 0 is not a code word. You don't see it in the set C3. So this has to be decoded as 0, 0, 1, 1, 0. So this is uniquely decodable. But in order to decode this part, you have to see until the end of the whole string. So this one is uniquely decodable, but this one is not instantaneous. It is not prefix-free code. Prefix. So as you can see, 1, 1 appears as a prefix to 1, 1, 0. So this is not prefix-free code. How about C4? C4, as you see, none of the code word appears as a prefix to other code words. 0 does not appear any one of these three as a prefix. 1, 0 does not appear as a prefix to these two code words. And 1, 1, 0, 1, 1, 1, they are the same length. So you don't have to worry about the prefix part. So basically, C4 is a prefix code, and this code is instantaneous. So if you concatenate any of these code words, you can immediately decode at the end of each code word. So let's say 1, 1, 0, 1, 0, 1, 1, 0. 1, when you read off from the start, 1 does not appear, so you have to read one more. 1, 1, 1, 1 is not a code word, so you have to read one more. 1, 1, 1 is a code word, so you immediately decode right there. So this is 4. So 1, 0, 1 is not a code word. 1, 0 is a code word. So that is the second one, which is 2 now. Then 1, 1, that's doing the same thing. 1, 1, 0 is the third code word, so it is 3. So you can decode this way immediately at the end of each code word. So C4 is an instantaneous prefix-free code word, prefix code. So C4 is a prefix code. Okay. So this sentence, 5 sentences actually, summarizes what we have studied so far. So see if these summary makes sense to you. A code C is a map from X to C. A code word is a string made of DRE alphabet. An extension code C star is a map from X to the kth power to the C to the kth power. So it's a concatenation of code words. A code C is uniquely decodable if all its extensions are uniquely decodable. A code C is a prefix code if it is instantaneous. So having said that, we can represent the relations this way. So there is a set of all codes. So any code which is a map from script X to DRE string, we can call it a code. A map is a code. So among all codes, we can divide codes into two kinds of code, non-singular codes and singular codes. So a map, which includes many-to-one map, is singular code. So it belongs to this set. And when it does not allow many-to-one map, then it becomes non-singular code. So it belongs to this set, non-singular code sets. So a code can be either non-singular code or singular code. And among non-singular codes, we can talk about the extension of the code. When the extension of the code is uniquely decodable, then we call it uniquely decodable code. So uniquely decodable code belongs to the set of non-singular code. Okay, among uniquely decodable code, if the code is also prefix free, then it is called prefix code. So prefix code belongs to the set of uniquely decodable set. So that's the summary of what we have studied so far.